Hello, I am Agi Karasugi. Thank you for visiting our work on face mask invariant end-to-end face recognition. Straight into the problem, the majority of modern face recognition methods commonly employ 2D alignment methods by warping detected landmark coordinates to reference coordinates, such as those used in MTCNN. The current COVID-19 pandemic causes people to wear face masks, which causes inaccurate landmark predictions that lead to misalignment, causing recognition performance to drop. Our contributions in this work are as follows. We introduce a face mask augmentation technique to enable the creation of face mask synthesized datasets. We analyze the effects of the face mask synthesized datasets in the alignment result and verification performance on SOTA method ArcFace. We propose using an end-to-end trainable joint face alignment and recognition architecture to align and recognize faces with masks. We selected Cassia web face for the synthesized training data and several available verification datasets, such as LFW, to be synthesized with face masks and used as testing data. We also used the RMFD dataset as real-world testing data in our experiments. Data synthesis protocol. We predict 68 face landmarks with daily shape predictor from each image in a dataset and selected 6 landmarks that will be used for the enter of a face mask. We randomly select a face mask images and split it in half. Each half will be transformed into target landmarks using previously chosen landmarks. We obtain the inverse binary mask and combine the halves into one. Using the inverted binary mask, we created a background image from the original image. By adding the background image with the world mask, we obtain a face mask synthesized image. Our proposed end-to-end recognition method contains 2 modules, alignment module and face extraction module. The alignment module utilizes a spatial transformer to align 128 by 128 face image into a post-normalized 112 by 112 size image. The localization network predicts an affine transformation matrix that provides freedom in scaling, translation, rotation, and sharing. The localization network architecture is a miniaturized ResNet with an FT layer that outputs 6 parameters of the transformation matrix. The feature extraction module can use any feature extraction backbones. Our method uses a ResNet 50 variant that outputs a 512 phase feature factor. Here, we can see that the network successfully aligns the face images into a stable position. By looking at the test result on LFW pairs, our method achieves significantly better performance on synthesized and half-synthesized pairs. In the ROC curve, we can see that our method's curve is far on top of standard ArcFace, signifying much better performance in those pairs. We can also see a significant performance increase in other test datasets, especially on synthesized CPLFW and CALFW pairs. On real-world RMFD dataset, our method achieves better performance on the mask-to-mask pairs and mask-to-non-mask pairs. By analyzing the saliency map of the methods, the performance difference can be explained. Standard ArcFace trend on the normal dataset factors in the face masks in predicting the feature factors, which is terrible because the face mask is not part one's face feature. Standard ArcFace trend on the synthesized dataset is more localized on the eye and forehead region. But our method is even more focused on an area that contributes more to discriminative features. We also perform an ablation study to analyze if the face landmark detected from unmodified images is used to align images with a face mask. The result is that the standard ArcFace method gains sizable accuracy improvement, but still falls behind our methods. The result proves that a different alignment approach is needed for recognition methods to learn the visible part of the face more effectively, such as our proposed method. To summarize our work, common face alignment methods have difficulties in predicting landmark locations, which results in an unreliable alignment that reduces recognition performance. We propose a method to generate face mask synthesized datasets that could be used as training or testing dataset. We explored the effect of the synthesized datasets on standard recognition flow in ArcFace method and propose an end-to-end face recognition network invariant to face mask. Quotes for our work are available at the GitHub link in the slide.